Thank you. We are open for questions. I think there's a lot of questions already in, in the chat. Let me read to you one by one. The first one is great talk. How much is complexity of designed part, especially in smaller samples, affect the mechanical performance of the 3D printed part?
So in some cases it can, in some cases it cannot. Where it is most useful is that if you are going to hear bad news, it is better to hear the bad news about a small sample than a gigantic sample. Am I making any sense?
I think so. I think so. Let's continue. There's a lot of interest here. One student's asking, was the recording available?
If I have access to the recording,
yeah, I will send to you. I will share with you. Yeah, I'll leave up to you. Yeah.
If I can edit a little bit, I know that several times I interrupted rather rudely because of my cough.
You're fine. You're fine.
Out and put them in the in my YouTube channel. You have YouTube channel link here. So many of my other talks are also there, and the talks of some of my students.
That's great resources. Yeah, thank you for sharing with us. Yes. The next question is, great talk, Professor. Is there a possibility of correlation of non-dimensional nodes with properties through machine learning?
Non-dimensional numbers.
Yeah.
Yes and no.
That's a tough one.
Yeah, you can, and we have done so. Our plots have a lot of scatter. So we have done that, but we have not done that very well. Maybe if we have a bigger team, I have benefited enormously by collaborating with many of my very talented colleagues from other institutions.
True, yeah.
If you can join us, I think our research would be a heck of a lot better than what we do now.
Yeah. Yes, Professor DebRoy is well known to collaborate with the National Laboratory as well. You know, Lawrence Livermore National Laboratory, Los Alamos. He's very open for all the collaboration, for sure. Yeah. A lot of questions. So let's continue. The next question will be whether laser wire additive manufacturing will dominate laser powder bed fusion.
Laser wire. Laser is more expensive than electric arc. So I think overwhelming majority of wire feed, where the primary motivation is to expedite production. You know, you're not making layers like 30 micrometer thick. You are making layers that are maybe 1 millimeter thick. And you can do that much more inexpensively using a gas metal arc power source.
Right. So, yeah, like a tungsten. Yeah. So the next question is about modeling. Is there a possibility to combine phase field model with mechanistic models?
Answer is absolutely yes. The mechanistic models can give temperature fields as a function of time, and any model would need that. So do we do that? No, we do not do it, but there are other colleagues of mine that do.
Okay. The next question is, unlike traditional metals, mechanical property for 3D printed part at micro scale will vary based on the process parameters, making it anisotropic. can we predict correct macroscopic properties through processing model or machine learning?
So I think we are beginning to do that. I have a colleague who just published a paper on tempering kinetics during additive manufacturing of H13 tool steel this year.
Okay. Yeah, so my group is thinking about doing that as well along that line. So we'll consult you this afternoon or local time.
Yeah, we collaborate with University of California in Berkeley, Peter Hoseman, and Los Alamos National Lab, Stu Malloy, and they are co-authors of us.
Yeah. The next question will be, how do you decide the number of cells in your mechanistic modeling? How big the cell, how small? How do you decide the number of cells?
The rule is that you keep reducing the cell size until the reduction does not change the results.
Here we go. That's a trick. Yeah. Okay.
Yeah.
Obviously, the smaller the cell size, the computational time, they're gonna take longer, right?
That is correct, but the computational time has a new meaning in this day and age. When a $800 laptop can solve 3 billion equations a minute.
Okay. Yeah.
Is it that critical? I mean, in 1980s, a supercomputer could not do it.
Let alone. Agree. Yeah.
So we live in a very different time, and the change has been so radical that we have not been able to integrate those into our curriculum yet.
Understood. Yeah. The next question, great talk. Could you please comment on how the machine learning can contribute to the AN of new materials like high-entropy alloys or ceramics? What properties are not well documented? He's talking about how can your machine learning use for the new alloys or new ceramic with a lot of unknown, basically.
I am not the right person to do so. I'll tell you where you may be able to find more information. My long-time collaborator in Cambridge University is Professor Sir Harry Badeshia. He maintains a website. So if you go there, there are lots of talks on those types of alloys, the high entropy alloys. Now, our book has a chapter on high entropy alloys, and the book was actually published in December of last year. Although Springer was advertising 2021, it was available to everyone last year. But there is a talk by Brian Cantor, Cantor, and Professor Cantor's talk is on Harry's website. So I suggest that you review that talk.
Excellent. So I expect to get a lot of more clicks. The next question, amazing talk, Professor. How will the law of machine learning accelerate the way in which we design novel alloys and material systems in the future? So I guess this is kind of similar question. How will the law of machine learning accelerate the way in which we design novel alloys, material systems in the future?
Yeah, I think one of the trends is to optimize for high entropy alloys. I am not too aware of that. My only, as somebody who does not do research in that field, my basic question is, how much is it going to cost? How many times the cost of gold for you to make that part? And who is going to buy that? And then remember, many of the papers I see, there are one or two properties that have been tested.
Mhm.
For most of the critical parts, we need toughness, right?
Right.
We need creep resistance. We need fatigue.
Mhm.
Is it enough to do one or two testing that we normally do for a paper to decide that question?
Okay. Yeah. Yeah.
I think a lot more work needs to be done.
Sure. Sure. So for the sake of time, two more questions. A lot of interest, Professor DebRoy. So, for developing mechanistic model for AN of new materials, could you please comment on incorporation of materials property, like temperature dependent, independent, and the mathematic heat source model?
It's always a key point.
Mm-hmm.
One of my students wanted to know the boiling point of 6061 aluminum alloy.
Right.
And his problem is, if you look at the vapor pressure data of magnesium,
Mm-hmm.
data over liquid magnesium does not exist at temperatures beyond, about 2000 degree Kelvin.
Right.
So where does one go? And I think a little humility is in order here. The best thing to do is to declare the uncertainty in the thermophysical properties, because they are incomplete. And in our paradigm of research, in which National Science Foundation proudly announces that only they fund what they call transformational research.
Mm-hmm.
Yeah.
Right. Okay.
Thermophysical data is not transformational research, it is incremental, and therefore National Science Foundation does not value it.
I see. But it's critical though for all this modeling.
It is critical. Anything that is tied to the standard of living,
Right.
to write a proposal to National Science Foundation, this is a waste of time.
Understand. One more question, and then we'll end the presentation. The question is, would molecular dynamics help to improve in the field of AN? By the way, Professor, that's a nice talk.
I think it can help in determining thermophysical properties, but
true. Yeah.
But atomistic simulation of parts that are very large,
yeah,
in terms of tens of centimeters,
yeah,
will need a lot of maybe quantum computing and other advances.
Right.
Right now, I'm not sure that it's a very easy thing to undertake.
Agree. Let's thank Professor DebRoy again. Everybody's kind of muted. So I pause for everybody. Thank you. Thank you again. My group will meet you this afternoon. Nice talk. I will send the video to you. Okay. Up to you too. Yeah.